Hi, good afternoon. So my name is Stephane Nicolas. I work for Groupon, and I'm going to introduce you to a library that we wrote around a year ago. It's called Dart and Henson, and actually there are like two libraries, two different modules. I will explain that a bit later. For those who are interested, Dart was written at first by a developer from India, whose name is Pratik. And we decided, so we released the version 1. We will see that it works great. It does a lot of things very well. And at Groupon, we decided to enhance it and to add a new module called Henson. And for the small history, Henson is actually the name of the first human being who reached the North Pole. He was an African-American. That might be interesting to know. And we have a small logo that illustrates this. He had some contact with the Inuits at the time. So, welcome to this presentation, Dart and Henson, Better Android Intents. So first, let me introduce myself. So I'm Stephane Nicolas. I'm a senior Android developer at Groupon. I started programming at the very beginning of Java, which is quite interesting when it comes to Android. It goes a bit faster to learn it. And I'm quite involved also in open source software. So recently at Groupon we released Dart, Toothpick. I got some other libraries that I wrote before joining Groupon, like Boundbox. So yeah, if you are interested, you can find all of them on GitHub. And we are actually two authors of Dart and Henson. The second one is Daniel Molinero Reguera, who couldn't join because we decided to split the conferences, and he gave a talk at Droidcon Japan recently. And Daniel is also an Android developer at Groupon, a very good level 3. That's an inside joke. I think it's hard to understand it if you're not at Groupon. And he's also involved now in quite a lot of open source projects. So together we wrote Dart and Henson that I'm going to present today, but also Toothpick. It's quite a good dependency injection engine, actually, if you're interested into this topic. Again, you can find our repositories on GitHub. We also publish our slides on Speaker Deck. And you can even find some videos or links of talks like this one. They are linked directly from the README of the GitHub repository. You can join us by using Twitter for Daniel. Here is his anchor. And I'm the very last Google Plus user, so you can join me with the plus Stephane Nicolas. Or write me an email. It's not so difficult to find, actually. So we both together, we work at Groupon. I don't know if, I guess most of you might know what Groupon is because we are present in Italy. So Groupon is an electronic marketplace to buy stuff on internet, from goods to travels or activities, whatever. And we have quite a big Android team, actually. We are like 40 developers in California, in Palo Alto. And we also have like 15 developers from Romania. They are also getting involved in open source projects right now with us. And so if you are interested to join us, you can just apply at jobs.groupon.com/careers. Actually, it's quite a good opportunity, I would say. We also have, I should mention it, a team in Berlin, if you're interested, to work on the merchant apps. So in California, we work more on the user application. Groupon is quite an interesting place, actually, to work, because not only we enjoy good working conditions, not so long working hours, which is really rare, I think, in the IT world, but also because we can spend quite a lot of time on research projects on open source. So right now we have already 2 libraries that we published since last year, and this year we want to publish also 3 new libraries or tools on GitHub as well. So we plan to open source more and more code. And it's a very dynamic place. We try all the new libraries, so our code is unit tested. We have continuous integration. Of course, GitHub's crazy webhooks. We work on design. We work on espresso testing. We use RX, Butterknife, name it, dependency injection. So if you're interested, just submit a resume. It will be welcome. I'm going to introduce you to the talk by showing this plan. So we're going to talk like a big picture of what is an intent and what are the extras inside the intents. After that, we are going to introduce the notion of a navigation layer inside an Android application. And later on, I will introduce the two parts of Dart and Henson. So Dart is one module that allows you to consume intents from a target activity. And Henson is actually used to create an intent from the source activity or source service, whatever. And then a little conclusion. Let's get started with intents and extras. So as you know, an intent is really an abstract description of an operation that we want to perform on the Android platform. It's one of the very big differences, I would say, with iOS, because intents allow you to navigate inside your own activity, but inside activities outside of your own application. So you can start something that belongs to other developers. It could be written by Google, by other companies, whatever. But you can also use intents, so you actually use intents, to open new activities or to launch your own services or broadcast receivers, whatever. So the intents are really like a core notion inside Android. Unfortunately, we will see that it has some design flaws, some shortcomings, and Dart and Henson are here to mitigate these issues. So yeah, from one entity inside our application, we can launch another one, basically. And we can describe not only the target to be launched, but also pass parameters. To pass parameters, we use extras. The extras are just providing an extended set of information so that the target activity or a target service can know what to do. Not only show up, but show up to do something for us. And in the same way, an activity can also communicate back to the source activity once it is finished. If you look at what you're doing at a very large scale inside your applications, you will see that your activities are going to form all together with the intents a navigation layer inside your application. It means that it allows your users to navigate from one screen to another or even to launch like background services. So the question is, how can we organize this navigation layer? How can we make it more robust, mainly, but also like efficient? So as any problem that we have in IT, it's usually a good idea to divide it. So when it comes to intents, there are actually two sub-problems to solve. The first one is how to create an intent, and the second one is how to consume the intent. So let's take an example from the Groupon business domain. We will have a deal list activity showing deals that you can buy on Groupon, and you can launch, when the user clicks on one of the deals inside the list on the left, you can launch an activity that explains the detail of the activity. It's just a Grouponization of the famous master and detail example that you can find everywhere on Android. So first, let's talk about how to consume intents. To consume intents, we're going to use Dart. So Dart is really the module that you will use to consume the intents from within the target activity. Let's say we have a target activity, so our deal detail activity. Inside this activity, we have a couple of fields that are Java fields of the activity class. So we have fields that are typed, like string, field 1, integer, field 2, boolean, field 3, and so on. And this activity is going to be launched. Suspense, yeah. Using an intent. So inside the activity, we receive an intent that asks us to display the informations that we have stored in our fields. Not yet stored, but soon. So we receive this intent, and this intent will contain extras. Basically, extras are passed as a bundle in Android, and a bundle is just a hash map, just a basic hash map, some key value. So hash maps are great. I think it's probably the most used data structure in all IT, but they have a huge inconvenience. It's that they are not typed, which means that you will receive value 1, value 2, and value 3, usually not very strongly typed. And also you have to know the keys by which the values are named inside the map. Let's look at what it gives on the deal detail activity. So very basically, you will define the two fields, deal ID, and whether or not you should show a map for this deal. You will have to define the two fields. Then you will have, during the onCreate method, so inside the onCreate methods, you're going to receive the intent is going to be available via getIntent. And so you can say getIntent dot get the extras. And to get the extras, you have to know the type of the extra one by one that you want to get from the intent. So get string extra and also get boolean extra. Some of those values are optional. For instance, the deal ID is actually mandatory, whereas the should show map value is actually optional. So when we get them from the extras, we are going to check also if the deal ID that we received is null or not. If it is null, then there is an issue in our application, and we probably want to crash as soon as possible during development. So here we get the stuff from the extras of the intent, and we null check the deal ID. We don't do the null check for should show map because it's optional. This value could actually be null. Moreover, you will have to define a few constants. So generally, it's a good idea to define them inside the target activity. So the constants are going to be the keys by which the values are named inside the extras, inside the bundle. So here we have a key for the deal ID value and a key for the show map value. All of this is actually quite a lot of boilerplate when you think about that, because you will have to do it in all your screen. And boilerplate means that it's not only boring, it means that it's also very, very error prone. After like 1, 2, 3, 4, 5, 10, 15, 20, 40 screens like we have in the Groupon app, you're going to probably introduce mistakes. And if you don't do mistakes in the first place, also what's going to happen is that it's going to be very, very difficult to maintain over time. As I said, we are like 40 developers, always developing new activities and always developing new ways for activities to communicate together. And so someone adds a feature, adds a parameter, someone wants to remove a parameter, someone wants to chain a parameter between two activities. And all of this is changing all the time with all the features that we have. And approximately every day we have like around 80, 100 commits on the master branch. So it means that there are a lot of changing, and over time, it's very difficult to actually track, even if a parameter is still required or not, if it's still mandatory or not, if it's still optional, if it's still used at all. So we just realized that inside our application, we had this very big issue. For maintenance, it was just a nightmare. So we decided to make things a bit simpler. Inside the activity, what we propose with Dart is just to annotate the fields. So what you can do, the deal detail activity, you declare your fields, the field 1, what of type string, the field 2 should show map of type boolean, and you can just annotate them with @injectExtra. It means that they are going to be received from the extra, and they can be mapped to an object. So you can see that also the should show map is actually nullable, which means that this extra is actually optional. Deal ID is not annotated, which means it's mandatory, it's required. When you are inside the onCreate methods, the getIntent, the intent is available. All you have to do is to say dart.inject this. And with this method call, what we're going to do is that we're going to use some code that has been generated via an annotation processor. So we are going to detect the extras, the @injectExtra annotations, and then enable. And we're going to generate all the boilerplate codes to associate your fields to the values inside the extras. And you don't even have to define the keys. All the keys are going to be like created for you just by using the names of the fields that you're using. So with these two powerful annotations and just a small call inside getIntent, then you will be able to completely fill or map your own fields to the values of the extras. So this activity is exactly identical to the first one that we saw together. So as you can see, we cut the boilerplates quite a lot. So here we actually bind the extras to annotated fields. One of the things you can do also, if you are interested in maybe a more designed application, is that you would like maybe to externalize the states or your fields, the deal ID and the should show map into a different entity. So we can also introduce a model that will receive the extras. So here we can define a model with the exact same fields, field 1, field 2, field 3, or deal ID and should show map to go in the same vein as our example. And you can use this model class and link it to the activity. To do that with Dart, it's very easy. So you just define your deal detail model. So it will just be a POJO that maps to the things that you expect from the intent. And then within your deal detail activity, you can create an instance, not now, of detail model instance. That's it. And then you call dart.inject, and you want to inject inside the detail model instance this, which means what you get from your intent. Here, this might be a little mysterious. Actually, there are quite a lot of overloads of the method inject. So you can inject from any bundle. You can inject from an intent. You can also inject from the save instance state if you want. So if you would like, that is also available with Dart. And you can put it into your own fields, as we did previously, or externalize it to a new model. And this model can then be used for your logic, your business logic. To set this up is quite easy. So there are two things that you would need to do with Gradle. The first one is to include inside the compilation scope the Dart runtime, so the runtime part of the Dart library. So you include it inside the compile scope, and then you can use the APT plugin or the new annotation processor, which provide a scope only for the libraries that you want to use during annotation processing time. And then you can use the Dart processor library. So both of them are available on Maven Central, so it's very easy to get them. You just add the Maven local or Maven repository to your build.gradle, and that's it. So that's the only things that you have to do. There are also a few parameters that you can pass to Dart, but I'm not going to go into these details right now. And we also provide a setup for Maven, if some of you are still using Maven. Yeah, it happens. So let's go back to the big picture. So we just solved one of the problems, actually consuming the intent inside the deal detail activity. The other one is a bit more tricky. How can we create an intent? How can we create an intent so that we are sure that we're going to pass everything and nothing more than what the deal detail activity expects? So from the left activity, we want to fill an intent for the target activity on the right. To create intents, we are going to use the second module of Dart and Henson, so Henson. Henson actually uses... Let's talk about how to do that without Henson first. So to do it inside the deal list activity, if you would like to do it manually, what you would do is to create an intent, then you need a context to create the intent, usually an activity, or an application in some cases, but yeah, usually an activity. And then you would give also the target activity class, here the deal detail activity class, and then you would fill the extras inside the intent. So it's like a builder pattern, so you can just change the dot operator. Here we create the intent, and then we add to the extra the deal ID and the should show map. And to put them inside the bundle or the hash map, what we're doing is using the keys that are defined inside the deal detail activity, if you remember. So we're just doing this manually. The issue is that it's not robust, because we can make a mistake. We can, for instance, exchange two keys. That's quite possible. But also for us, as I told you before, the real issue is how to maintain that over time. We have an application that is 7 years old, so from the very beginning of Android, maybe more than 100 developers contributed to it with different styles. Things are getting better, but still we have quite a lot of legacy code. And as I said, we are publishing new features in every release, every 3 weeks, and 40 people, maybe even 50, if I include the team in Romania, are contributing to these features. And so everyone is changing all the time everything inside the intents, and it's quite difficult to keep track of it. What is really necessary, what is optional, what is not used anymore, what is used maybe not in the target activity, but in the next one, if you have a chain, like a flow. Or sometimes we have complicated flows. For instance, you open the Groupon application, you go through the deal list, you select a deal, you press buy, and then we will ask you to log in. You go to the login activity, and then to get back to the buy screen once you're logged in. So we have this kind of flows where we would pass the deal ID not for the login screen itself, but for the screen that is going to open after that. So this is quite frequent as a requirement, I guess. So yeah, doing this manually is not only painful and not very interesting, but it's also quite error-prone and really difficult to maintain over time. So one of the alternatives that we could use to try to solve this problem would be to actually create like a God activity that knows how to build intents for all of your activities. It can look like a funny idea, but when I joined Groupon, actually we had that. So for 40 activities, it means that you have 40 by 39 by 38, 40 factorial possibilities of navigation. We didn't explore all of them, but we had like 1,500 lines of code just to build intents in a single class. Wonderful. And also, one thing that is very tempting for developers, if you create these kind of monsters, and it can be very quick. It can look like very funny at the beginning, but I'm so sure that there are so many of you or companies you work at that actually did this, because it's a simple pattern, you just put it somewhere. So one of the temptation is also from one of these methods to call one other. For instance, if you want to go to purchase, then you first call the method to create a login intent, and then you call the method to go to the purchase, and you chain them like this, which means that if you change one method, it actually impacts like maybe 5 or 6 flows. Really nice. So, yeah, this code does have issues. At least there are some things that are good. If you look at the signatures of the methods, they all return intents, okay, that's fine. But also they have parameters that are strongly typed. So you know at least the type of the things that you're going to pass, like the deal ID. Also, one advantage of these methods is that they are actually completely masking the fields that the keys that you're going to use inside the bundle, which is nice. So you don't have to worry that much when you're going to use the methods. You're just going to pass the parameters that you want, and you more or less guess where you want to go by the name of the method. So this is a good point. But as I said, there are also a few shortcomings. So basically, from a design point of view, the first big mistake in this one is that we are infringing the Mayer's open-close principle. So if you don't know about that, the Mayer's open-close principle says that a class should always be closed and open, but open for extensions. So you should allow some extension points, usually interfaces, so like a listener for a button, for instance. So this can be a way to open a class, but it should be closed so that the problem that the entity or this class is actually trying to solve doesn't grow. It doesn't grow exponentially, or it doesn't grow over time. Here, we're doing exactly the opposite. It means that if you add a new activity, you're going to add at least one method inside this central intent factory. At least one method, maybe 2, 3, 4, or changing other methods. So this class is always changing. And always changing means that it's all going to always break, basically. And also, as I said, it can also turn out to be a complete ball of mud where no one is able to understand what the application is doing after a few iterations, just because the methods are calling each other. So you look at the code, and you just don't understand what is happening inside your application. But it works. Until yesterday, it worked. So that's what happens for real. One of the things that you can do to improve that is to avoid a central intent factory and to create the methods to create the intent, so the IntentBuilder methods. You could create them in the target activity. It's already a bit better. So you could do that with static methods, for instance, or you could have a static inner class that would be called like IntentBuilder, so deal detail activity, and inside a static inner class IntentBuilder, which provide the static methods above. So here we would just put the same methods only to go to deal detail activity. and they are just building the intents to go to this activity and only this one. Already it's a bit better. It's not going to grow exponentially. Also, you can completely privatize the fields for the keys that you're using, the constants, so that they are not exposed to other parts of the application. So no one is going to make any mistake using them, which is nice. So you can have this kind of pattern. It's actually not so bad, but you have to do it for all of your activities, which means it's boilerplate code. And again, boilerplate code is not only boring, it's also very error-prone, because you can still swap the keys, you can still add a method quickly with a new parameter. Also, think about it. You will have to create methods to, to allow all possible combinations of your arguments. So if you have 2 optional parameters, then you would have to create, and 4 mandatory parameters, you would have to create 2 methods, or even 3 or 4. So one with the 4 required, and that's it. One with the 4 required, 1 optional, 4 required, 2 optionals, 4 required, the other optional, and so on. So all the combinations of them, which is just very boring to do. So yeah, that's just boilerplate code. How can we do better using Henson? It's pretty easy, actually. We're just going to reuse the exact same annotations that we have been using for Dart. So if you remember, when we have been using Dart inside the target activity, we had the deal detail activity, and inside it, all the fields that were linked to the intent, that we wanted to map from the intent, are just annotated. So here we annotate them with @injectExtra, @injectExtra and a label. It's the exact same example as before. Under the hood, what Henson is going to do is that we are going to generate an intent builder for you. So the annotation processor is going to generate this code, which is exactly what we wanted to do the slide before. So having a dedicated class that writes all the boilerplate code to deal with all the combinations of the attributes. But it actually does it a bit better than what we saw. So what we're doing is that we're generating a small DSL, a small domain-specific language, which means it's basically a state machine. So when you want to use one of these intent builders, you will say new intent builders of my activity, then you will pass a context that is used to build intents, and then you just type control space, dot control space, and then you can see the name of the first parameter that is required just by completion. Then you give the value. Dot control space, the second parameter that is required, dot control space, the third one. And if they are optional, you will be able, after you filled all the required parameters, then you will be able to fill only the parts of the optional parameters you want to fill. So it's really like a nice state machine, very convenient, very readable. Also using the chaining of the dot operator, so you can just align on the dot and it leads to very clean code. And there is no mistake in that, because everything is completely generated for you. At the end of the intent builder that is generated, you have the build method that returns an intent, and this is exactly what you wanted to get, the intent to reach the deal detail activity. So you can use this class from everywhere, from a service, from another activity, whatever. Let's have a look. So first you fill the context. Here you can see that we fill one required parameter, the deal ID. Then we will fill one should show map parameter, just passing a boolean. By the way, maybe I didn't talk too much about that, but you can use big B booleans or small b booleans. Both of them are possible. You will just get a small lint warning if you use @noLabel with a primitive type. That's a lint check. Yeah, we should actually open an issue for that, maybe. Talking with Tor, yeah. So, and then once this is done, you call the build method. So here is an example of what it looks like to actually use an intent builder. One of the nice things is that we don't generate only intent builders. We also generate a class named Henson, which is the Henson navigator. So this class, Henson, has this syntax, Henson.with, and then you specify the context used to build the intents. That's it. And then you go to deal detail activity. All of that is generated for you. So basically, once you've typed Henson.with control space, you can see how to go to any of your activities. All of them have intent builders that have been generated. So you can go to deal detail activity, and then you will see the name of the fields that you have to pass. And again, the small state machine that we're using inside this chain operation is going to actually enforce the required parameters and the optional parameters. So you don't have to worry about the combination, about missing something, it's not possible anymore, about adding something that is not used anymore, it's not possible neither, and something that would be optional, you think it's required. All of that is completely clear now. And then you build, and you get an intent, and you do whatever you want with it. You could use it right now to start the activity for result. You could put it inside a pending intent and pass it to a remote view, whatever. So all of that is possible. So here, you can see that the Henson class provides a small fluent API. I forgot the name, so it's also called a DSL, domain-specific language. And all of that, again, is completely generated. One of the things that is actually very specific to annotation processing is that to detect that we can go to one activity, we need an annotation, so that the annotation processor of Dart knows that this annotation is actually navigable through Henson. So if you have fields that are annotated with @injectExtras, then automatically Dart detects this annotation, and it knows that the activity that contains it is navigable. So we will create a Henson go-to method to go to this activity. But some of our activities are actually not, they don't have any fields that are annotated with @injectExtras, that they don't use the extras. But still, it could be nice to navigate to them using Henson so that our code base is completely homogeneous. So to do that, you can take any activity, even not using extras at all, and you can just use @Henson navigable on the class of the activity itself. Once you've done that, this activity is going to be detected by the Henson annotation processor, and we will create a Henson go-to setting activity method that build, and you got an intent. So you can actually completely generate all the navigation layer to go to all your activities, and all your intent builders are going to look exactly in the same way, which means the problem is solved from our perspective. Also, we mentioned at the beginning that it was possible for an activity to have an external model that would be just a simple POJO that contains the fields that we want to map from the activity. So here again, it's possible to do that when we are creating intents. So we can separate the extras and the activity, which is a good design idea. A bit in the same way as we separate the logic of the presentation with the presenter and the activity itself, being a passive view. So here we can just define a model class, the deal detail model. Again, we annotate the fields as we did previously in the activity. We just externalize it to a model class. And now the deal detail activity itself doesn't contain any injected field. So we have to use @Henson navigable to say to Henson, hey, I want to go there using Henson Navigator. So @Henson Navigator, and you precise the name of the model class that you want to use. When the annotation processor will read this @Henson Navigable model equal deal detail model.class, then it will generate for the deal detail activity a small Fluent API including all the fields that are annotated inside the deal detail model class. Just very basic, at least simple. To do that, again, the setting is very simple. So you have two parts to the Dart library, exactly in the same way as you had two parts into the Henson library. The other way around, actually. So to configure Henson, you just, inside the compile scope, you put the Henson runtime. So it means com.f2 product.dart Henson and the version number in Gradle. So this belongs to the compile scope because we need a few classes to be included inside your APK. And again, you can use the annotation processor scope or the APT plugin from Hugo Vesser. I think he gave a talk recently this morning. And you just give the name of the annotation processor for Henson. And that's it. using this annotation processor, we're going to generate all the intent builders and the Henson class that you can use to navigate to your activities. Again, we provide the Maven setup if you didn't catch up yet with Gradle. So, yeah, as a conclusion, we actually think we solved the problem. Which doesn't mean that it's not going to come back in a different form. So, yeah, we wanted just to generate the navigation layer so that it's not an issue for our programmers anymore. So we were really bored of having these kind of issues that are very hard to detect because it involves a lot of conditions inside your application. Maybe you will be using this parameter, maybe not, or maybe it's going to be used in the next activity or in 2 next activities. So it was really difficult to keep track of that, so we wanted to just generate the code and get rid of the problem forever. So with Dart and Henson together, we could achieve that in a very elegant form, according to us. And actually, yeah, we've been using it for more than 1 year now. And it's also quite possible to unit test it. There are a few tricks if you use dependency injection to do that right. And yeah, everything is working. If you're concerned about performances, as we are at Groupon, everything is using generated codes. So basically, we don't have reflection, except I think we still, oh no, it's optional. You can use reflection or not because of the first DEX issues anyway. So yeah, if there is a question about that, we can dig this. So yeah, we wanted to solve the problem forever. So instead of writing always the same code and making mistakes and being unable to maintain it, we just generate it. If you are interested, I think it's really a good library, actually. Do you guys have any question?